So now we have to predict whether a person will have diabetes or not. So here I am going to check. So we have to go with the cell type. So top cell, and I'm going to change the cell type to Markdown. That means this is not going to run as Python. It's a Markdown language. So run this first once. So which is a kind of nice mine. We are working on it. Now you should be familiar with doing all of our imports. We are going to import the pandas as PD, import numpy as NP, pandas is pandas data frame, and numpy is a number array, very powerful tool to use in here. So we have our imports. So we have bought in our pandas our numpy to general Python tools. You can see over here. So our train stat splits now. I used to be familiar with splitting the data. We want to split it for training, and then for our particular model we want to go ahead. So test the remaining data to see how good it is. So we have scalar preprocess, so we don't have a bias of really large numbers. Remember, in this data there are many of them, and what are the amount of insulin they are taking it up to 256. So 256 versus 6, that is a skew results, so that they are all uniform between -1 and 1. Then the actual tool here is k nearest classifier. We are going to, and finally the last three are the three tools to test all about our testing how good our model is. So we have our confusion matrix, our F1 score, and our accuracy. So we have our two general Python modules we are importing. Then we have our 6 modules specific from the sklearn setup, and then we need to go ahead and run these. So we are actually imported, and then move on to the text step. We are gonna ahead load the database. We are going to use pandas. Remember, pandas is PD, and the data in the Python in a simple spreadsheet. But usually I like to use these our data set equals read CSV. There is a panda command, and then the database folder I just put in the same folder where my Python script is. So if you put in a different folder means you need the full length on that. We can also do a quick length of the dataset. That is a simple Python command for length. We might even, let's go ahead and print that. We will go print, and if you do it on its own links, then dataset, then put a notebook, it's automatically printed. But when you are in most of your different setups, you want to do the print in front of that. Then we want to take a look at the actual datasets, and since we are in the pandas, we can simply do the dataset here, and again we add the print in there. If you put a bunch of these in a row, you know the dataset one head, dataset two head, it only prints out the last one. So we keep the print statement in there, but because most project only use one data frame, pandas data frame, doing it is in the way, the other way works just fine. So you can see when we hit the run button, we have the 768 lines, which we know that we are having a parentheses. It's automatically given a label on left. Remember, the head only shows the first 5 lines. So we have 0 through 4, and just a quick look of the data, you can see it matches that. We looked at the, before we have pregnancy, glucose, blood pressure, all the way to age. Then the outcome on the end, we are going to do a couple of things in the next step. We are going to create a list of columns where we can have zeros. There's no such thing as zeros in thickness, or 0 blood pressure, or 0 glucose. Any of those would be a dead. So not a really good factor. If don't, if we have a 0 in that means it didn't have any data, because we are going to replace those information with a couple of different things. And we have look, so first we create a nice list. We have the values talked about: glucose, blood pressure, skin thickness, and this is a way of working with the columns. To list the columns, you need to some kind of transformation on a very common thing to do. Then for a particular setup, we certainly good use the some panda tools that will do a lot of this. So we can replace a in bar a or a not a number. So go ahead with the dataset columns that equal to, so don't replace this. So this still pandas, you have a direct look. So you have to replace those NaN values with the help of a numpy. So as a not a number value, so we are replacing the 0 with the numpy none. There's no data there. So that's what this is saying, right? So put the 0 in, and we are going to place zeros with no data. The 0 means the patient will hopefully not dead, or they just saying we are going to create the mean, which is the integer from the data set from the column mean. So where we have skip these things. So there's a panda command, then skip. So we are going to figure out the mean of the data, and we have to replace that mean value. So this is that NP, which means that you would have actually just taken this step and go right down here and just replace the 0, skip anything. So actually there is a way to skip zeros and then just replace all the zeros in case we have to go ahead with this. So we are switching this to a non-existent value, and we are going to create the mean. Well, so this is the average person. So if you don't know, so what is this? Then you didn't have get the data, and the data is missing. one of the trick is that we have to replace them with the average value. So what is the common data for that? You can still use the rest of those values to do our computation, and it's kind of our just brings that particular those missing values of the equation. So let's go ahead with that and run. It doesn't actually do anything, so still we are preparing our data we want to see. So we don't have anything in the just first few lines, so it's gonna certainly going to look at the row. Let's do in our data sets with the printed data sets, and let's pick in this case let's just do glucose, and if I run in this is going to play all the different glucose levels going down, and we don't see anything in here that like a missing data value. So you have a bunch of values are there. So by using either Jupyter Notebook or Colab, we are going to run this. So remove this, we'll just zero out, or we have to proceeding any further. We need to split the data sets into our trained and testing data. So we have to train it with the, notice that we have a little something here with the pandas database code that we're going to draw here. So in this data set, it's saying it's a first one is in the pandas. This is from PD pandas. It's going to say within the data sets, we want to look at the I location, and it's all the row that say we are going to keep all the rows, but we are only looking at the 0 column 0 to 8. And remember column 9 here, it is right up. Here we printed it here as outcome. This is not part of our training. So column 9, but it is listed as 8, number 8. So 0 to 8 is 9 columns. So 8 is a value. So we are calculating from 0. Okay. So if you are taking 8 columns means we should take with the 0 to 7. So go down here to Y, which is our answer. We want just the last one, just column 8 with this particular notation. And then if you remember, we imported the training test splits part of the scalar right there, and we simply put it in our X and Y. We are going to do random states equals 0. So that's a seed number. I think the default is 1. When you seed it, I have to look up it, and then the test size is 0.2, which means we are going to take 20% of the data and put it aside, so that we are going to test with that data later on, and we are going to run. It's not everything exciting. So we are going to look at the data that is so once you prepare it, its actual lines of the code are quick and easy. So we are almost there, but the actual running of our KNN, we need to go ahead, scale, we have to scaling the features. So we are fitting the data and a scalar data 5 to 303 in one column, and the next one is 1 to 6. We are going to set that all the data is between -1 and 1. That's what the standard scalar does. Keep it standardized, and we only want to fit the scalar with the training set, but we want to make sure that the testing set is X test going is also transformed, so it's processing at the same. So here we are going with the standard scalar AC underscore X, and we are going to import the standard scalar into this variable, and this X train equals XC underscore X, do it a fit transform, and we are creating the scalar on the X train variable, and then our X test we are also going to transform, and we trained and transformed the X train, and the X test is not part of the training actually. It's actually just transform that all it does, and again, and now we have gone all these three of these steps of them. So we are replacing our zeros, so 4 key columns that should be 0, and replace that with the mean of those columns. So the way they fit it right with our data models. So we have to come down, we have to split the data. Now we have to test our data and our training. So we have scaled the data, so all of our data is going, we don't need train the Y. So why the test need to be done, we want to train in that define the model is k nearest neighbor. So on that fit the training data in the model. So we do all the data preparation, and you can see here a couple of lines of code. We are actually building our model and the training. That's one of the cool things about the Python. And however, we have to come in machine learning because there are so many automated tools here available. So here we just do the length of Y, and we get 7 or 68. So if we import math, we do the math dot square root. So let's do Y train. So there we go. It's actually supposed to be X trained. Before we do this, let's go ahead and do the import math square root of Y. When I run these two, I get a 12.409. I want to see where the number comes. We are about to use 12 is an even number. So if you know, you're going to voting on these things numbers. So even number of neighboring voting. So we have to make it as odd. So we will take it as 11. So we move into the coding section. Again we have to run it. So put it on the classifier. We are creating our classifier. It's going to be the k nearest neighbor, and it equals to the k value is 11. So 12 minus 1. So is the R number, now it is 11. And we are looking for this whether it is a diabric or not, and we are using the euclidean metric. There are other means of measuring the distance also. That Manhattan is also available. So these are all kinds of measure. So it works quite well. It is important to evaluate the model, and it is similar to the top confusion matrix. So we have to compare with the actual and predicted value. So we will jump into the F1 score and finally an accuracy score, which is probably the most commonly used evaluation model. So here you have to paste this evaluation model. So that CM that is equal to confusion matrix, the weight test that predict, we are going to put that and run that and print it out. The way you interpret this is why the predictor, which should be title up, and here you have to do the PRIDI, the prediction. It's across the top and actual going down. So it's always hard to write here actual. That means that this is a column here down. So this is an important column and makes that it's our prediction set 94 and the prediction is actual agreed on 94 and 32 number. So here is 13 and the 15. Those are what the values. So three different. So if you are looking across these three different values, instead of just two, you can end up with the third row down and the third column going down the middle. So the first case, so I believe the 0 has a 90 for the people who don't have the diabetes. The prediction said 213 of the people did have diabetes. We are at a high risk, and the 32 had diabetes if had correct, but the prediction said that 15 out of 15 it's classified as incorrect. So you can see whether the classification comes in and how that works on the confusion matrix. So that we are going to go ahead and print the F1 score. So let's see that this 0.695652. So that F1 takes into account of both sides of the balance of false positive. So where if we go ahead with just do the accuracy, what the value is 0.8181 and then go on. So this is the type of accuracy that we are getting. So that F1 score that must be calculated. So the general public decision makers in business, they are going to ask what the accuracy is. So the accuracy is always better than the F1 score, but the F1 score is more telling that just know that they're more false positive. So we would take the accuracy as 82 percentage, which is not a bad value for it. So I'm running on a sklearn and running the KNN on the nearest neighbor. So we have created a model that is based on this KNN classification algorithm. So it classifies whether that person is having a diabetes or not. So it tells that 80% accuracy is pretty fair fit in this model. So finally we get an accuracy of 80%. Thank you.